Alrighty, looks like there is a part 2 to part 1 yesterday. It's also medium, not hard. Okay. You're given a string S consisting of characters A, B, C. The substring S is balanced if all distinct letters in the substring appear the same number of times. All distinct letters in the substring appears the same number of times. Return the longest balanced substring. This looks okay. Yeah, this is longer than before. Okay, so I did do a bit of kind of study with the AI in terms of learning the overall concepts behind arrays with kind of frequency mappings, and I think I should be better able to tackle something like this. Apparently you can use a kind of a state tuple, a prefix state tuple, and encapsulate the state at any index, and then see if you return to that state later on. Let's see if I can try to work it and then come up with some sort of description of what it did. So here, balance if all distinct substring letters appear the same number of times. So I need to think about every index having a particular state that encapsulates the frequencies of A through Z, where if you go back to the same state, you are balanced. Oh boy. The definition of move to the same state is being balanced. So if all distinct letters in the substring appears the same number of times, longest balanced substring. Let me think. A, B, B, A, C. So it's obviously A, B, B, A. How would I encapsulate that? All distinct characters in the substring. And then here, A, B, C, C. So somehow these two have to have the same state, and these two have to have the same state. Or from this index to like this index has to be the same state. 1, 2, 3, 4. So inclusive of A, inclusive of B, inclusive of B, inclusive of A. All characters have the same. So I think the example had to deal with the differences between the frequencies. So if I did So if my A here, let's say I do the frequency of, say, I encapsulate as the frequency of A minus the frequency of B minus frequency of C. So the first, at index 1, it'd be 1, 0. At index 2, it would be, there'd be 1A, 1B, so difference there would be 0, 1. Frequency of B minus frequency of C is 1 minus 0 from there. At the third index, it'd be 2 B's minus 1A, so that's negative 1, negative 1, negative 1, 2. And then at this third one, at the fourth one, 2A's minus 2B's is back to 0. 2B minus 0C is 2. And then at the third one, 2A minus 2B is going to be 0. 2B minus 1C is going to be 1. So that doesn't work. 1, 0. The longest bound substring is 2A, 2B. So if I'm at a particular state, how would that even work? If all distinct characters in the subarray, all distinct characters in the substring appears the same number of times. Can I even encapsulate something like this? Can I even say that they have the same state? Moving the same. A, B, C. If I think of A, B, C as movements in a three-dimensional space, so I start with 0, 0, 0. Think of just the sum, just the count of each of those frequencies. Each time I see an A, I move. Each time I see an A, I move right. B, I move up. C, I move in. right, up, in. So that'd be right, up, right. A, B, B, A, right, up, right. I need somehow to translate A, B. A, B needs to translate to something where A, B needs to translate to something where it maps the same spot, I think. A, B needs to map to the same spot in some fashion. BA needs to map to the same spot in some fashion. In theory, if you have, although technically A by itself would need to map to the same spot in some fashion. Oh boy. Yeah, I definitely did not. Whatever I just studied does not cover this. Balance of all distinct characters in the same substring appears in the same number of times. All distinct characters. Did it not? No, it had to cover this. I see the difference. It had a guarantee as to how many distinct characters there were. It's guaranteed that there was A, B, and C that was going to be equal. This one is just whatever's there. I see. Well, I kind of see. I kind of see. So the understanding before was the state was like a relative difference between the frequencies of like one value and the next value. So if you had, let's say, initially 4 A's, 3 B's, 2 C's, 4 A's, 3 B's, 2 C's. If you were to add to that, let's say, an additional 5 A's, 5 B's, 5 C's, and you get a string that has 9 A's, 8 B's, 2 C's, or 7 C's. If you map it into relative differences that were like A minus B is 1, B minus C is 1, A minus B is 1, B minus C is 1, then like your state is now the same state as at the end of this part. So if you compare the number of indices since you've seen this earlier state, then you'll know how long the substring is, that is going back to that same state. But here you don't actually, you're not guaranteed to know what letters are in the substring. A, B, B, A. ABBA. Quite the band. ABBA. ABBAC. ABBAC. Yeah, Can I still find some variation in this? Wouldn't work if it was something where I tried to guess the letters in the string. Obviously wouldn't work there. Well, oh, interesting. The S only contains A, B, C. Okay, so the balanced substring is only all A's, all B's, all C's, A, B, B, C, A, C, or A, B, C. Okay, so there's what, 6 possible singletons, so there's 3. Doubles, there's 3. Triples, there's 1, so there's 7 possible. 7 possible variations of this. Okay. Maybe I can just handle each of them. Maybe I can just handle each of them. Using a separate, so I mean, handling all the single letters, just the longest streak of any particular letter. Okay, let's say define longest single, and I'll pass in the letter. And this will be something like long, long, I guess long is not a keyword in Python, I don't think. Obviously it's a keyword in Java. Okay, let's say the longest is 0. I guess I should probably have a streak as streak. I guess long is the streak counter, or current streak is 0. While, actually, I guess I do a for loop. For every letter, for every character in the string, if that character is the letter, I guess maybe I can keep the longest streak of each. I guess we can do a single pass. Yeah, whatever. The character is the letter, streak increments. I guess if it's not the letter, then I can do something where long equals max of long and the current streak. Else, actually I probably should do it like this. Else, actually there is no else. Streak resets to 0. Streak increments. Return long. And then I'll just test this out. So long A is equal to longest single S, A. Long B is longest single B. Long C is longest single C. Print long A, long B, long C. Not good. Oh my gosh, I'm stupid. Streak. If it's not equal to the letter, give it back to 0. Actually, yeah, there should be an else here. Yeah. Not my greatest. Okay, yeah, 1 is the longest A, 2 is the longest B, 1 is the longest C. Or wait. C should be 1. Okay, forgot the fence post issue. A long equals max of long streak. Alright. 2, 1, 2, 1, 1, 0. Sure. So next up is getting the longest combination, AB or AC or BC. Interesting. I could do something simple like where I just splice the string into separate chunks that all have splice the string into separate chunks where they're all oh, what is the simplest way? What I'm thinking of is mapping it from ABC to some binary string where the binary is the zeros and ones are the 2 letters I'm concerned with counting. I might have to splice the original string to get rid of the other character, the unused character. Something like that. Can I do this in a list comprehension? Oh, I don't. Seems a little iffy to try to do a list comprehension of this. Okay. So let's say define longest double. I'll do letter 1 and letter 2. And this is going to return the longest, or return length of longest substring with let1 and let2 only. So like with only A's and B's or A's and C's. So first I'm going to map string to array of binary strings. Letter 1 is going to be mapped to 0. Letter 2 is going to be mapped to 1. So it'd be something like B strings is going to be an array. For every, I guess I'll just do index equals 0. Is that right? Current is equal to an empty string. So I guess I'll call these, I guess I'm just mapping to a binary array. String to array of binary to an array of binary arrays. So I guess this is binary arrays. For every character in the string, if that character is letter 1, then the current appends 0. Else, if the character is letter 2, current appends a 1. Oh, I saw another syntax of this. It's like, do it like that, maybe? I'm not sure if you can tab, to be honest. And then else, 0, 1, or you need to make a new array. So this syntax is probably not going to work for this, or this, not syntax, this spacing. Else, binary arrays appends the current resets. And then I think I need an extra fence post here. If current binary arrays appends the current. Guess I can just try it out here, print the binary arrays. And let's do longest double AB, longest double BC, longest double AC. So what am I expecting here? Not this, I don't think. No, actually that's right. So the longest thing here is 0110. Yeah. And then here, I see if it's appending an empty string or empty binary array. I guess here there should be else if there is something in the current. Okay. So that's right. And then for, actually, I think I want a slightly harder test case. Let's say, let's do another ABBA. Okay, so there's 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, that's right. So it's like the ABBA maps to that, and then the second ABBA maps to that. All right, second one is B's and C's. So here, B's and C's, 0, 0 for that B set. And then that's just 1, and then BB. Okay, 0, 0, and then B's and A's. So that's it, just A and C, just A. Okay. Okay, I think that's fine. So now that I have my binary arrays, I wonder if there's a way for me to not process things that are too small. I think maybe I can do something where current best ignores it. So let's say the answer is equal to max of long, I guess I'll probably do long single and long double just to make this shorter. Long single of A. Oh my god. Long single of B. Long single of C. And here I can say if the thing is current and the length of current, actually I guess I can just do length of current. Length of current is greater than greater than should this be else? It needs to reset each time. So it's not A, it's not B. So if it's C, I guess, yeah, it should be else here. If the length of current, I guess it should be else current. Else if current. There has to be some better logic here. If the length of current is greater than the answer, then append. What is the way to phrase this logic? Like I want to reset the current if it's not the one of the two letters that I'm looking for. But I also don't want to append it if it's not better than. I guess maybe I can. Else. See here, I guess maybe I don't care if it's 0. Length of current is greater than answer. Okay, so that narrows it down to things that are actually possible. Okay, so now I'm dealing with a binary string or binary array, and then I just need to do the same state process here. difference between, well, I don't even have to do difference. I just do, like, I can, I guess I can do mapping of them to 0 and -1. Or 1 and -1 and take their sum. Mapping them to 1 and -1, take their sum. Their sum is their difference. The sum is the difference between A's and B's. Is that right? So if there's 5 A's and 2 B's, the sum of that would be, the sum of that would be 3, 5 plus -2. Yeah, I guess so. It's basically a prefix sum here. Zero. Yeah, you're walking up and down. Sure. So if you're getting back to the same prefix, or yeah, you're getting back to the same prefix state, then it should be the same state, the same number of letter A and letter B, letter 1 and letter 2. So if so for every index, I guess. For every binary array in binary arrays, or I'll just do array. I think you can do something where I guess I could even process the binary array right here. Yeah, whatever. For every array in binary arrays, okay. Let's see. I guess this is gonna be prefix sum. I guess this might be just a state dictionary. And the dictionary should have the initial state, which is 0 gets mapped to -1. State is, or the key is going to be sum of, I guess the key is just the prefix sum. And then the value is the index. So I think for every array in binary arrays, for every index, or let's say n is the length of this array, for every index in range n, I guess this should be here. So take into, I guess this needs a sum. State is going to be 0. State plus equals the array at this index. And then I'll say longest is 0. Mm. I wonder. Okay, anyways, if state is equal to state plus equals 0, if state not in state dictionary, then the state dictionary for the state is equal to this index, else longest equals max of longest, and the difference between this index and the first time it occurs. State dictionary for this state. And then I think that might be it. Did I forget to do? Okay, if current, actually this should be if length of current is greater than answer. And then I just return this, return longest. And then I think I probably should do answer equals max of answer longest double. I'll do this singular separately since this might update the answer each time. A and B. Whoops, I changed this to long. A and C, B and C. Let's see. Let's see what it has here. There's kind of a bit of, what's the term? There's a bit of side effects, because it doesn't quite, it's not quite encapsulated in terms of what this function's doing, because it does refer to answer. So therefore, it's not quite, if I try to diagnose if it's doing something correctly, it might not fully isolate the effect. Anyways, let's see what it has. Oh. Well, it crashes, right? Sure. Longest double not defined. Four, three, 4, 2, and 2. Yeah, okay, this is 3 because the answer is actually ABC, which I haven't done yet. Just doing longest double. Let's do another test case. Let's say there's another AB here, so the answer should be 6 for test case 3. Test case 1, yeah. Alright, so now it's going to be the longest triple, or long triple. So for this one, let's say again, define long triple. I guess I don't need to pass in anything here. Okay, so I think I will go ahead and remap ABC to like ABC to 0, 1, 2. Does that make sense, or do I just go straight into it? Because here I think I can just do the difference thing. I think I just go straight into it. State dictionary is equal to 0, 0 is going to be -1 index. Key equals state, where the state is the frequency of A. Okay, I'll say here key is equal to state, which is the tuple that is frequency A minus frequency B, comma frequency B minus frequency C, and the value is the index, the first index where that state occurs. And then I'll go count. I'll say frequency A equals frequency B equals frequency C equals 0 for every. Can I do for each loop? For every letter, or I'll just use ch and string frequency should I map it? Should I remap it? 1 Okay, if the character is A, then frequency A increments. Else if the character is a B, frequency B increments. Else frequency C increments. Wonder if this works, this tabbing. Yeah, whatever. The current state is going to be frequency A minus frequency B minus frequency C. If the state is in the state dictionary, guess I'll do not in. Then the state dictionary for the state is equal to this index. I guess I need to do longest. Else longest equals max of longest. And index minus state dictionary at the state. Return the longest. Answer equals max of answer and longest or long triple. Return answer. Unsupported type. Do. Did I misspell state dictionary? It's a tuple. This state is a tuple. What's going on? Index. Index is unknown. I must. Alright. Index. Alright, n is equal to length of this string, I guess. For every index in range of n. character is the string at this index. Okay. Okay. Interesting. Well, I wonder. I mean, performance-wise, it's not bad. It's a little wordy in terms of coding. Probably should just do a helper function here. It would make it slightly more complex to read, but it would decompose it slightly better. Would possibly remove the need for this binary arrays, this arrays of arrays. Just process the arrays. Process the array at the moment where I find it. Okay. I mean, that's what I want to do. Yeah, I'll decompose it just a little bit. I mean, I think the runtimes is probably gonna get worse just from randomness, but whatever. Process double, and I'll do passing the binary array. And here, this is going to helper function to find longest substring of binary array. Longest balanced substring. So it's just going to use the same code right here. I guess I'll call this array. And this should be something like just copy this portion. N is the length of the array. State dictionary, state. It is the prefix, so key is the prefix sum state. State increments, or state increased by the value at this index. If it's not there, put in there. I guess I need to have longest. Right? I could probably longest. And then I would call that helper function here. So I'll call this to be longest here. I guess I can remove this. And I can say if the length of current is greater than answer, then longest was max of longest, and process this array. This array being the current array. And reset the current. Same thing here. Longest equals max of longest. process the current. Return the longest. Slightly longest is bigger than answer. The length of current is bigger than answer, and length of current is bigger than longest. Okay. Yeah. So that helper function should work. Process is not defined. Oh, it's called process triple, right? Process double. Okay. $633. So slightly improved. I wonder, can you somehow encode this? Yeah. Thinking somehow encode the character ABC into some sort of digit, some sort of number where the numbers somehow combine to something equivalent to the differences. I don't think fractions would work. Fractions, you could always multiply the fractions. So if like encode ABC into three numbers, three integers, where A minus B is some value and B minus C is some other value. It's like 2, 1. No, it's not like some sort of quark system. I don't think that works. Unless I map A and B into. No. Alright. Guess I'll keep that portion right there. Summary. So decompose the problem into kind of three distinct subproblems. So A, find longest substring, or longest substring with one letter. Longest substring with two letters, AB, AC, or BC. Then longest substring with three letters. Alright, A should be pretty simple. Find longest streak of A, B, or C. That was just like, we've seen that plenty of times. Find the longest streak of something. That's going to be obviously balanced because it's all the same letter and that frequency. B, this is akin to finding the longest binary string or longest substring in of a binary string. It's zeros and ones. This is this also very common problem. Can use prefix array where zeros map to -1 and zeros map to -1 and 1, well, where zeros map to -1 and 1 map to 1 and find same sum in, and if same prefix sum, then the difference between those indices represent represent a subarray that is balanced. So something akin to, like, if you do 0, 0, 1, 1, 1, so there's this, so the sum up to the fifth one is going to be 1 because it's going to be -2 plus 3. So the state there is going to be 1. And then if you append onto it, let's say another, I don't know how many that's that. Let's say 6 zeros, 0, 0, 0, 0, 0, 0, and 6 ones. The state there is going to be -8 plus -8 plus 9. So which means that the state, which is defined as the sum of the values up to that point in the array, if you see the same state, then you can see the difference between the indices. The difference between the indices is going to be the length of the subarray that has the same number of zeros and ones. So you just do that mapping. So you map, this is the helper function. Well, this is part of the helper function, just splices the original array into something that has just the 2 letters that are corresponding, that you want to look for. Like, let's say letter A is A, letter 1 is A, letter 2 is B. So it just finds it. Once it does, it creates that string or that array of zeros and -1s, and then it does the processing here. Maps the state. The state is the sum prefix sum. The value is the index into a dictionary, and then just tries to find the longest occurrence of the difference between the current index and the previous first index of that state. And then the last one is, see, this is the hardest part. Trying to find the longest substring with all 3 letters. Use a prefix state similar to part B, but instead of prefix sum, it's going to be prefix kind of difference tuple, where it's going to be frequency of A minus frequency of B, frequency of B minus frequency of C. And you can see that here. If you have just the first 9 characters of the 4 A's, 3 B's, 2 C's, the state of that would be 1, 1. Frequency of A is 4, minus frequency of B is 3, so it's 1. and then frequency of B minus frequency of C is also 1. And then if you add on to it, let's say 5 A's, 5 B's, 5 C's, and you get new counters, new frequencies of 9A, 8B, 7C, the differences, or the difference tuple that is the state would be just also 1, 1. So getting back to the same state is getting back to the same, indicates that the difference between those indices is a subarray that is equal in the frequency of A, B, and C. So when two indices share the same state, indicates that the subarray between those indices have the same frequency of A, B, and C. All right, keep track of the longest, update, and return. Minor optimization is to continually only process or continually check if the current substring can improve the answer. Only if it can will you process it. All right, time complexity. This is going to be O of n. Yeah, it's O of n because every processing is since every processing of a subarray is occurs in O of k time, where k is equal to the length of the subarray, and all subarrays are disjoint. Well, all subarrays within one type, where the type are A, B, and C, are disjoint. You don't actually, it's not overlapping. Yeah. And then space complexity, this is O of n as well, since using hash maps, using subarrays, subarray conversions to like 0, 1 to like 0, -1, or -1 and 1. User space equal to the length of the string, and also hash maps, or yeah, state dictionaries can have up to n entries. Okay, cool. If possible, please code in Java as well. Oh my lord. It's an odd request. Can I? It's been a long time since I've coded in Java. I'm just looking at someone asking for something in chat. Java code. Hmm. Well, I'm not going to code this one in Java because it's been a long time since I've done that, and I would honestly spend at least as much time coding this as coding the solution in Java as yeah. I spend as much time coding this in Java as me just coding this thing in Python first time through. I will go ahead and try to bone up on my Java before I attempt any sort of solution.